Multiple applications and multiple versions running concurrently, the nightmare of every database developer. To manage the multitude of coexisting schema versions within the central database, the current best practice is handwritten delta code, so for instance views and triggers. This is already challenging, but by far not the only problem. With evolving and coexisting schema versions, at some point in time, we will have to change the actual physical schema, which is a giant task in practice. Besides writing the migration script, we also have to rewrite all the existing delta code. But good news, INVERDA, the tool we present today, fully automates database versioning and makes it foolproof. First, we will show how to create different schema versions, and second, we will show how to maintain them during physical restructuring. The key idea is to describe new schema versions with a more powerful evolution language. We call our language INDEL. Using its richer semantics, we generate all the delta code automatically. Let's write a database application to manage tasks called Tasky. Tasky runs on desktop machines and persists its data in a central database. So this is our INDEL editor with the already prepared demo evolution. We create a table with the task, its author and the priority. Let's also add some initial data right here. We simply execute this evolution script over the context menu and that's it. In the console, you may see the generated SQL. For demonstration, we implemented the INVERDA Explorer. Here it is. On the left, it lists all created schema versions, and on the right, you can insert, update, and delete data on any schema version and observe the effect on the remaining schema versions. Here we see the created schema version Tasky. But let's do some evolution. Users would like to see their most urgent task also on their mobile phone, so we integrate a third-party mobile app called Do. To match its schema, we filter the task with priority 1 with this statement. Then we drop the priority column and assign the default value 1. Let's also consider another evolution right now. After the initial Tasky app successfully runs a while, we continue its development with a typical normalization step. We separate the author from the tasks, call them just persons, and rename the author column to name. Let's execute it and see what happens in the INVERDA Explorer. On the top you see the initial version followed by the mobile do schema and the new normalized Tasky 2. All the schema versions stay accessible for both reading and writing. Let's test it. Assume Anne is out with her friends and they decide to have a party at the evening. Anne wants to organize it and immediately notes this down with the mobile do application. This task occurs in the remaining versions as expected. After the party, Anne is at home and deletes this task using the desktop version Tasky 2. Hereby, it is also removed from the remaining versions. As you see, the propagation between schema versions has been generated fully automatically when executing the INDEL scripts without any manual effort. So, we are able to generate different schema versions and the delta code, but how to maintain them during physical restructuring? This is actually really easy with INVERDA. Assume we observe 99% of the workload on Tasky 2, so we simply migrate the data accordingly to increase the performance. By executing this very simple script, INVERDA automatically changes the internal table structure and regenerates the delta code of all schema versions accordingly without any further interaction. So, summing up, INVERDA successfully uses the richer semantics of INDEL to automatically generate all the delta code, particularly views, triggers, and migration scripts. This tremendously simplifies the database developer's life and should end the nightmares. Thanks for your interest in INVERDA. Feel free to approach us for any questions, feedback, or ideas.